Okay, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera for Greentech 2020 presenting our paper prepared by me, Rohaida Nura Anwar, Encik Muhammad Fidaus, Muhammad Zubli and Puan Aminah Osman. So our topic for this paper is the development of sustainable energy lake recreation center using off-grid solar photovoltaic system. Okay, the outline of this presentation today is I will start from introduction, problem statement, research objective, literature review, methodology, result and discussion, conclusion, and finally the references. Our research basis for this paper is was come from the Malaysian government announced in 15th conference of parties in Copenhagen that Malaysia was committed to reduce the greenhouse gases emission intensity gross domestic product up to 45% by year 2030 compared to 2005 levels. So accordance with the National Renewable Energy Policy and Action Plan, where stated the vision to enhance the utilizations of renewable energy resources in Malaysia, then the various solar project was introduced. As supporting this National Green Technology Policy, educational institution including PISAS was implementing renewable energy projects on the campus. Okay, if you can see the background of this slide is actually the lake at the Pisas. So the lake in Pisas is used as recreation and water sport training area. However, this area has no electricity supply and also have no internet facilities. The cost to installing the electricity supply lines and the long-term energy bill costs are uneconomical. So this is the main reason why we put the renewable energy source at the lake. So the objective of this research is to present the development of the Sustainable Energy Lake Recreation Center, which is the short form from this is SELREC, using the off-grid solar PV system at Polytechnic Sultan Azlan Shah. Also, the next research objective is to calculate the energy cost saving and the carbon emission reduction cost by using a solar PV system as a power supply for lighting at SELREC. Okay, the research objective of this paper. So the objective of this research paper were to present the development of the Sustainable Energy Lake Recreation Center, or the acronym is SELREC, using the off-grid solar PV system at Polytechnic Sultan Azlan Shah to calculate the energy cost savings and carbon emission reduction caused by using a solar PV system as a power supply for lighting at SELREC. Okay, our research is based on past study for several papers, several research. So some of them uh, is from Po Chen Shu, conducted research on solar photovoltaic system for self-consumption at National Taiwan University, where the system is not connected to the grid. So the PISAS also PV solar panel from PISAS also is not connected to the grid system. For the research of Eliza Terrigan conducted the analysis of the rooftop PV at University of Surabaya, Indonesia. Through the installation of the rooftop solar PV at their building, the author also calculate the greenhouse gas emission CO2 reductions. So from Othman and friends has calculated the potential energy solar production with consideration in Malaysia based on average of 4.5 hours to 8 hours of free bountiful sunshine every day. So in our paper, in this paper, we assume that the calculation for uh, for solar production, energy solar production is around 4 hours. Okay, this is our single line diagram for off-grid solar PV system at SELREC. We adapt this single line diagram from Sharon Nizam 2019. So from this system, we can see that our solar panel have equipped with the battery, inverter, also the load. So we have here several loads for the to light up the light from the solar panel energy. SELREC business development using solar energy evolved equipment, such as we have three monocrystalline photovoltaic panel, 12 over 24 volt charger controller. We also have the power inverter, 3000 watt power inverter, fully automatic DC to AC inverter. We have a battery, uh, 3 battery, 110 ampere hour, 12 volt, sealed lead acid, to operate 20 units of 10 watt and also 20 watt floodlight around the lake. SELREC precise development process is starting from we analyze the light intensity using the appropriate apparatus. After that, we set it up the feeder filler. The feeder filler is where we put the batteries, charger controller, inverter at one space and put right after the PV solar. After that, the installation of PV frame and the PV solar will put on top of the frame. Next, we do the underground cabling. The underground cabling is inlay from the feeder filler to the floodlight around the lake. So the last step is we do the floodlight load installation. Floodlight, which is the load installation around the lake. And the final step is we do the testing process. We do the testing process to make sure all the load is function well. Okay, as a result, here from the photo, we have a SELREC during daytime, the photo taken from daytime, and also the SELREC during nighttime. So at the daytime, you can see the PV solar is located near the lake. We can see here, this is the PV solar is located near the lake to power up the load, which is the light floodlight around the lake. And during the night time, we can see the floodlight is turning on to operate to light up the lake at the night time. Okay, this is the energy cost calculation. For calculate the energy cost by assuming the efficiency of the solar panel is around 85%, the energy generated by the solar PV system per month is calculated as the energy generated per month is equal to power generated times total hour times efficiency times 30 days, which is a 1 month. So the power generated is around 0.72 kilowatt, 4 hours beautiful sunshine, times the efficiency is around 0.85 times 30 days, and result is 73.440 kilowatt hour per month. The amount of energy generated by solar PV panels subsequently supplied to the battery is around 73.440 kilowatt hour per month, and for year it will the energy cost is around 881.28 kilowatt hour per year. Okay, for calculate the energy cost by referring to the TNB tariff block, which is PISAS is commercial C1 commercial C1 group of tariff block. So the energy consumption we calculated already calculated is around 881.280 with the rate 0.365, because the energy cost saving is around 321.67 per year. This is the energy cost saving that we calculated based on energy consumption produced by the PV solar. When we calculate the carbon emission reduction for SELREC PV solar, so the potential of the carbon emission reduction has been calculated using the formula below. Electricity energy generated by solar PV is equal to 881.28 kilowatt hour per year. So the greenhouse gas is equal to electricity energy generated by solar PV times emission factor EF. It will this emission factor we take from Academy Science Malaysia 2013. This is our reference for emission factor for calculate the carbon emission reduction of PV solar for SELREC. So the equation is the electricity energy generated by solar per year times 0.670, and it will cost the 590.45 kilogram carbon CO2 that we save, that we deduct from the PV solar. Okay, as the conclusion, SELREC was developed using the solar energy and become a platform to support sustainable development and conserve the environment. It also supports education, awareness, and promote the widespread application of the National Green Technology Policy. Also, based on this research, the development of the SELREC using an off-grid solar PV system will allow PISAS to achieve energy cost saving around 321.67 per year, while the value of the carbon emission preventable from the SELREC development area is around 590.45 kilogram of CO2. Okay, lastly, this is our references to do the research for this paper, the development of sustainable energy lake recreation center using off-grid solar photovoltaic system. So this is the end of our presentation. This is the end of my presentation. So thank you for your kind attention. Thank you. Bye.